Yeah, as Jonah said, my name is Kent Blackburn, and um, I've been with LIGO for 30 years. Today at Caltech specifically. Today I want to talk about the public portal for gravitational wave data, um, or in other words, the introduction to Gravitational Wave Open Science Center, which we call GWASC as a pet name. Here on the screen, I've got a little screen snapshot of the homepage for GWASC, and the URL is at the bottom. It's gwasc.org. So if I go on, why open data? Well, let's start with the definition of GWASC. GWASC is the Gravitational Wave Open Science Center. It's a public data repository that provides free access to gravitational wave data from LIGO, Virgo, and CAGRA. I should have also included GEO. There is some GEO data in there. This data is released under the Creative Commons license 4.0 for those of you that follow that sort of stuff. And obviously, if we have this significant of a project, we need to have goals for a project like that. And some of the key goals that we have in place are to promote accessibility, transparency, and reproducibility of results. Make sure that the science that we do is good science. It also fosters collaboration and interdisciplinary programs. Jamie gave a great example of that for the multi-messenger binary neutron star signal. And I do recommend people go and read that paper. But we also want to enable new discoveries from existing data. And I'll talk a little bit about that in a little while. But for now, the contributors to the GWASC are the LIGO Scientific Collaboration, the Virgo Collaboration, and CAGRA, which we call LVK for short. But we've also started to include results from the broader community. And this includes things like software publications and more recently, community catalogs, which I'll give an example of. So there's quite a bit of variety in the data that's on GWASC. So I call it Data Plus Plus. And I'll go into the details of all of these later through the talk. But we have the strain data that Jamie was talking about. We have segment lists or graphically timelines. And we have measurements of the data quality, basically flags, whether it's good or bad, for a few different characterizations of data quality. We also have event catalogs. These are the events that have been detected and published. They include search parameters, parameter estimation parameters for all of the events, at least the ones that are confidently detected. There's lots of documentation you'll find all over the place. There are references to publications and even additional data beyond what's available on GWASC. There are the tutorials and the workshops like the one we're in right now. And as I mentioned, you can access software, web apps. There's a new GWASC API, I think, since the last time, or maybe it's been there for a year now. But also there's libraries for all kinds of data analysis and use of the data that you can find. The data itself, the strain data itself, is found in two formats. There's a GWF, which is gravitational wave frame format. That was a custom format developed by LIGO and Virgo many decades ago for sharing data between LIGO and Virgo. And for the most part, the LVK software that's used to analyze the data uses that format to get started. But GWASC is also distributing the data in HDF5 format, which was developed by the HDF group a very long time ago, but it keeps evolving and becoming better. Which is useful for storing and organizing large amounts of data, and it includes lots of metadata and is very efficient and widely used by lots and lots of open source software. There's also several other formats for smaller files, that have various snippets of information in them. You can find stuff in JSON, CSV, and also ASCII on the GWASC website. So getting the observational data. Well, what observational data do we have? We've already completed and it's already available to download data from observational run 1, which we call O1, O2, and O3. And Jamie pointed out that we're about halfway through O4, which will be coming soon, soon meaning roughly a couple of years from now, depending on where in the '04 run, it appears, and we have a future plan for an '05. So that's on the horizon as well. In this particular cartoon, you can see the individual detectors and little bars showing the time that the data collection occurred in. And we don't run continuously. We take breaks, we improve the instruments, and then we start another run. So that's why there's gaps between each of these. Um, Getting the data just involves going to our home page. So if you go to the GWASC.org website and you go to the Get Data at the top, it's a menu that you can click on. When you click on that, you get a download option. And if you go to the download page, you'll see a page of where you can select which data you want to get. And there's event data at the top. There's the observational runs as you go further down. For example, I've circled the O3B data release. On the right, you get a choice of whether you want a lower sample rate or a higher sample rate of the data, 4 kilohertz, which means 4,096 samples per second, or you can get 16,384 samples per second if you click the 16 kilohertz data. There's also links to documentation and timelines here. But I do want to point out an important feature if you want to work with a lot of the data, and that is just to go to this link and follow the instructions and directions for using OSDF, which kind of gives you a virtual file system on your computer that mounts all of the data remotely over the network. If you click on that particular button for the O3B, in this case, the 4 kilohertz data set, it takes you to a page that looks like this, and it shows you the times that you had selected. I've selected well, let's see, no, this is the whole run I have here. You can select which instrument. For example, H1 is shown in this picture. You can select the time range that you want from that observing run. So I've picked the start time plus 1 day. I only want to grab 1 day of it. And then at the bottom, you can click on choose your output format. So there's 4 different types of output that you can get, but I've selected the time series data with HDF and frame files and the data quality guide. So you just click the continue button and it takes you to this page, which shows you the GPS time of each frame file or HDF5 file, the size of it, what percentage of the data in it was in observing mode or one of the data quality states, the CBC Cat 1, Cat 2, Cat 3, burst Cat 1, Cat 2, etc. Those are data quality states that affect the data analysis that we do internally in LIGO. And then on the far side, you'll start to see some of these injection flags. And they all start with the word no, meaning no for 100% says that there's no injections of that type in the data, which is another important thing. If you want to download that file, you just click on either HDF5 or frame, and it will download to your computer locally that one file. What about segments, timelines, and data quality? Well, segments are basically just a list of start and end times that characterize the state of the detectors and any irregularities that might have implications for astrophysical searches, such as the CBC Cat 1, Cat 2, Cat 3 flags I mentioned, or the hardware injections. During any of the time intervals, the detector may or may not be in observing mode. There's activities that occur. An earthquake may bring down the instrument. They have routine maintenance that they perform. There's many reasons why the instruments may not be collecting data, even during an observing run. And so we capture that in these segment lists. Any irregularities in the detector occur using additional instrumentation or environmental state. I mentioned earthquakes as an example. These are labeled as Cat 1, Cat 2, Cat 3 flags that may interfere with the searches. And typically they're CBC and burst Cat 1, Cat 2, Cat 3 flags. But coming in the next release, the 04 release, will have 2 more, stochastic and continuous wave. So look for those in the future. They're man-made injections. These are hardware injections that either simulate an astrophysical signal or simulate a noise feature of the instrument. And they are usually injected for the purpose of calibration, search sensitivity, or in rare cases to challenge scientists. Uh, and they're called injections. The times when these are added or not added are part of the segment list that I showed earlier. Um, you can get the segment information when you download the GWF or HDF5 file. They're actually in there with the strain data. But you can visualize it or download them separately, but the files themselves also have that information. And when you are working with the segments on the website, you can display them graphically as timelines. You can download the segments in either JSON or ASCII, whichever one you prefer. So how do you get them? Well, we go back to that home page and we go to the Get Data and we click on the menu for Get Data, and you'll see a timelines option. So you just click on timelines. It takes you to a page like this, which gives you a lot of information about the run that you want to look at, the range of GPS times that you want to look at. You can change those if you like, which I've done here. I've just made it one day, 86400 seconds. You get to select um, the the format that you want to view or get the data, the segments in. You have a choice of plot, JSON, or ASCII. And then there's a little table that lets you choose what types of segments you're interested in. Are you interested when the instrument's in observing mode? Are you interested when there are exclusions due to any of these Cat 1, Cat 2, Cat 3 um, data quality flags, or even hardware injections? And when you're ready, you click Display. But before we click Display, let's just look at some of these. So the data quality flags are broken up into 3 sections. At the
Okay.
top in sort of the gold rectangle are the data quality Cat 1, Cat 2, Cat 3 flags. In green in the middle is when the instrument's in observing mode, and at the bottom are when the hardware injections are occurring. So I've clicked on several of these from the box. You can click as many as you want, but I just clicked a few as an example. And when you click Display, you come to a page that looks like this. At the top of the page, you can get some timeline statistics, basically how many seconds the instrument was active, what's the duty cycle as far as being in that particular state, and the number of segments that occur in that time interval that you selected. At the bottom, you see a little graph that shows the segments themselves. So here I'm showing one of the hardware injections for H1. It looks like DETCHAR. So there were no DETCHAR hardware injections during the time I selected. Then I show H1 data, which is when it's in observing mode. You'll see that's broken up into 4 segments because it was not continuously taking data. Only when it's read was data being collected. So there were a few times when the data collection dropped out. And then I have one of the CBC Cat 1 as an example, data quality flags, which agrees perfectly with the H1 data. Because there were no issues with the data quality that would impact a CBC search for Cat 1. Now, if you want to look at the actual segments themselves, you can click on JSON, download as JSON. You can click on ASCII. I'm going to do it with ASCII. And then you pick which of those data quality flags you want. Let's look at the H1 data. And you get this in ASCII. So basically, it's giving you the GPS start time, GPS end time of that data quality, which is when the machine is observing, and the duration in seconds for the observing segment. And you get a list of 4, which is what we saw in the graph. So let's move on from that and start talking about events and catalogs, or the event portal. So the event portal is a gateway into the events and catalogs, and we consider the catalogs as groupings of events typically related to the observational run or a subset of the observational run that the events are found in. And they're also referred to as releases, basically stating when they appeared in GWASC. Some catalogs have marginal events. These are events that did not meet all of the criteria for being a confident event by the searches, but we've made them available anyway. There is a GWTC which stands for Gravitational Wave Transient um, catalog, which captures all the confident events found by the LIGO Virgo Cagra collaborations. And we've recently started a program for including catalogs from the broader community, which we call community catalogs, which will hopefully give us a more complete view of events that are part of our data that we release. So how do you get there? How do you find the event portal? Well, you go to the Get Data again. This should be becoming routine by now. And you click on the Events and Catalogs option. It takes you to a page that looks like this, where you have four options. But also, I don't want you to overlook that little Help button up in the top right-hand corner. That has lots and lots of information that's useful for understanding events that are in the GWASC website. So there's four of them here. There's at the top the GWTC transient catalog, which captures the LVK confident detection events. There's the releases, which lists the releases of catalogs that have appeared on GWASC. There's events, which shows all of the events, whether they're marginal, non-marginal, from within the LVK or not from within the LVK. And then there's a query form where you can down select a subset of events that might meet some criteria that you're interested in. So if you click on, we'll go through each one of these one at a time. But if you click on the transient catalog link, you'll go to a page that looks like this. This page shows that we currently have 93 confident events in GWASC. There's a table at the bottom that shows each of the events and some of the basic parameters of the events, like their masses, the network SNR, the distance to them, etc. If you click on any of those events under name, the name column, it will take you to what's called the single event page, and we'll look at that in a little bit. But next, let's look at the releases page when you click on releases from the event portal. This just gives you a long list of releases, a little description, and you can click on any of these. For example, if you click on the GWTC, it'll take you to the page that we just looked at, but you can look at the individual releases by clicking on any of the ones below it. And so the next one was the all events one. And this just shows all of the events that are in GWASC. You can see the number is about twice as large, 182. So there's almost twice as many events in GWASC as our confident detections, but they may have some implications or interest for people, and they're all listed here as well. If you click on the query form, you come to this form where you can search based on criteria that you specify. You can look for events of a certain name. You can look at a subset of the releases. You specify the mass range, chirp mass, distance, whatever you like. The time intervals, whether you want the output to be HTML, JSON, CSV, or ASCII, and then you just hit the submit query at the bottom to get that particular query of events from the database. And I promise to show you the single event page when you click on one of the events in the table. It looks something like this. There's a lot of information here, so I won't go through all of it, but there's metadata about the events. There are search results here. The parameter estimation results are here. You can get links to the PE samples that were used for the parameter estimation, links to the sky maps. The Q transforms are plotted here. The little thumbnails with the purplish background that you see. Underneath those, you can download the data for that event. There's 32 seconds, 49.6 seconds for most events, HDF5 or GWF format, and even text for many of the events. And then something that's a little bit newer is the interactive plotting, which is called the event view, or event viewer, sorry. And if you click on that, it takes you to an off-GWASC site page at previewer.igwin.org that gives you a lot of information about individual events. You can select the event here. You can select up to 3 events. You can look at the sky maps, all of the parameters, a subset of the parameters. You can see the waveform reconstruction and a lot of other very useful information that you can find and play with in this really entertaining website that's linked from each event. And then I promised to say something about the community catalog information. Community catalogs are sort of a new thing. In fact, last week, I think it was, we released our first community catalog on GWASC. It's the IAS-03A. It's from an outside community. They're part of a group at Princeton. On this page, you get a little bit of information about what community catalogs are and some links to basic guidelines for contributing to the community catalog. So the catalogs themselves can be authored by people outside the LVK. They can be included on GWASC. We were just looking at this web page that has the information on it. They're carefully vetted. That's important to make sure that the information there is scientifically meaningful and vetted. The goal is to include a full set of gravitational wave discoveries available in the scientific literature, not just the ones from the LVK. It's not meant to include every reanalysis. Instead, focus on works that discover previously unknown astrophysical transients. The catalogs are added to the event portal, but they should also be published in a respectable, peer-reviewed scientific journal. And the guidelines for contributing to the community catalog are in this link. And as I already mentioned, there is one already up and available, but we have plans for more in the near future. There's a lot more on GWASC. Let me just briefly go through those. There's a section on tutorials where you can click on Learning Path, tutorials, workshops like the one we're in right now. There's software where you can get web apps. You can convert GPS time to UTC time. There's a source visibility check that shows you when interesting GRB signals occurred during our observing runs. There are software libraries that you can download. And then there's this new programmatic interface for accessing the data on GWASC under the API documentation. And that looks like this. And I think as this is kind of a new and upcoming way of working with what's in the GWASC database, it's worth spending a little bit of time learning about it when you have time. And then, of course, the last tab at the top is About. And there you can find out about GWASC. You can learn about acknowledging GWASC, a very important thing for us since we're funded by an outside source. And you can contact us. There's contact information and a list of papers and projects, not just from within the collaboration, but other contributors to GWASC that have interesting projects or interesting papers that might be useful. And I want to specify one here, this was written by the GWASC team, and it kind of gives you an overview of what the data is in GWASC for the latest O3B open data release on GWASC. But we do one of these for every release of data that we have on every observational release of data that we have on GWASC. So you can find in the past others from previous observation runs, and going forward there'll be papers like this for future observing runs. And I'm sure that we're running late, but I want to end with the fact that I didn't get to tell you everything. So here's a fun quote from Feynman that I hope that shows some success in sharing information with you. And I hope you'll be challenged to learn more in your spare time, because we have so little time to learn. And the best way to get there is to come to these things like our workshop today.